Hello students, and welcome back to another video lecture from Architects Academy. Today we are going to learn about stub column and stanchion fixing detail. So in the first figure you are seeing what is called as a steel stanchion. A steel stanchion is nothing but a column which is made in steel sections. As you can see in the figure, this particular column which we are seeing here is made up of two channel sections which are connected together by steel plates called as batten plates. At the base of the stanchion you can see that there is a base plate which is fixed to the stanchion by means of these triangular shaped plates called as stiffener plates. You will also see that the base plate has got holes in it which will correspond to bolts which are going to be placed in the stub column. Now at the bottom you will see that there is a RCC footing which is we call as a rectangular RCC footing, and from that footing there is a RCC column which is coming out. The column is of a short length. It is only up to the plinth height of the structure, and because it is of a short length we are going to call this as a stub column. You will see that the steel stanchion is provided with a RCC foundation for obvious reasons, because if we provide steel foundation below the ground it would be acted upon by moisture inside the ground and it would get corroded. Now while we are casting this steel column, there are bolts which are placed in the stub column which we call as the anchor bolts or foundation bolts. These are cast along with the column. You will see that these bolts or foundation bolts have got a plate welded to them at the bottom. This plate is important because when there is an angular or horizontal force acting on the stanchion, it has a tendency to bend, and as a result of that it has a tendency to get pulled out of the foundation. Now if these small plates were not provided, then the bolts also would have a tendency to get pulled out along with the column. So the function of these plates is that they fix the column, the bolts into the column and prevent the pulling out action of the bolts. You can also see that all these bolts, foundation bolts, they are connected at the bottom with the help of a steel rod. It is necessary to connect them at the base because we need to keep these bolts in exact position, in vertical position, while the concreting is being done for the column. They should not move with respect to the column because they have to be exactly aligned in the position and they should correspond exactly to the holes which are made in the base plate. Now once this is done, the steel column is fabricated or manufactured outside. This particular stub column and foundation has already been cast. Now this steel column which has been fabricated outside is lifted up with the help of a crane, and then it is slowly lowered down onto the pedestal in such a way that the holes exactly correspond to the foundation bolts in the stub column. So you will see that the bolts go through these holes and the steel column gets fixed on to the stub column. Let us go to the next slide and just see a position where the steel column has now been fixed to this particular stub column. What you are seeing here is the RCC stub column. You are seeing the anchor bolts with the small plate at the bottom. You are also seeing the base plate of the steel stanchion and the stiffener plates. You are seeing that the bolts have gone through the stiffener plates, and you will see that the steel column is now fixed onto the pedestal. Now, one important thing that you should note is that while fixing this steel column to the pedestal, a gap is left or maintained between the top of the stub column and the base of the steel column. The reason for this is that we need to adjust the level of the steel column, that is the vertical level, and therefore some gap is required to adjust this level. So once this column is placed in position, the verticality of this column is checked with the help of plumb bob. You are possibly aware that the plumb bob is used for checking the verticality. So once this is brought into perfect plumb, that is, it is brought into perfect vertical level, the gap here between the top of stub column and the base plate is filled with a cement grout. But this grout is slightly different from the standard grout which we have, and it is called as a non-shrink grout. The reason for having a non-shrink grout is if we use a standard cement grout, after the cement sets, it will have a tendency to shrink, and if it shrinks, again a gap will be created in this space. So the non-shrink grout ensures that this is completely filled up and there is no shrinkage. Now let us again see this in the form of some other three-dimensional sketches. As you can see here, this is the foundation for the RCC column. This is the PCC at the base, and you are seeing this as the column footing. You can see the stub column here. You can see the foundation bolts. Now purposefully we have not shown the reinforcement inside the column because we want to explain how the foundation bolts are put, but there is going to be reinforcement inside the column. You are seeing here that this is a trapezoidal footing. In earlier case we had seen that this was a rectangular footing, but it doesn't matter. It could be trapezoidal or rectangular footing. So once this is completed, this photograph is showing you how the stub column is going to look like. You are seeing that the foundation bolts are jutting out of the column and ready for the steel column to be fixed on top of them. You can also see that there is some steel reinforcement which is coming out here. This is for joining the plinth beam which is going to come from the side. Now in the next sketch we are seeing the steel column which has been brought from a crane and it has now been fixed on top of the foundation bolt. So you can see the foundation bolts are going through the base plate. In the next sketch you can see, or in the next photograph you can see how this would look like in actual reality. You will see that this is the stub column. You will see there are some small nuts here also at the bottom called as check nuts, which will maintain this gap between base plate and top of steel stanchion. And you can see that this is now the steel stanchion has been placed in position. The next step would be that we will be leveling the steel stanchion. So by using the check nuts and by moving this column slightly, we will bring it in exact plumb, that is vertical position. Once that is done, then we can fix the nuts on top of these bolts and we can fix it finally to the stub column. So you will see that in this case you are now seeing the gap that is left between the base plate and the top of the stub column. After the verticality has been checked and the final level is achieved, the gap is filled with the help of a non-shrink grout to complete the connection between the steel column and the RCC pedestal. So this is how it is going to look like once it is completed and it has been fixed in position. So that was all regarding the method of fixing stub column and stanchion fixing details. Now here is a short note on the same topic. The main salient points of the short note have been given. So let us just go through these points one by one. A steel column is called a stanchion. The foundation for steel column is a RCC foundation for obvious reasons, because as I explained that if we give a steel foundation, then there is a possibility that it will get corroded because of moisture within the ground. The stanchion is designed to carry loads of structure, that is vertical loads, and loads due to wind and other horizontal or angular loads. The column has a tendency to get pulled out of the foundation due to angular loads. Hence, it has to be properly fixed to the RCC foundation. Vertical part of the RCC foundation is the stub column or the short column. Foundation bolts are cast in the stub column during construction. The steel stanchion is provided with a base plate which has holes corresponding to the foundation bolts. The steel stanchion is placed over the stub column in such a way that the bolts pass through the holes in the base plate. A gap is maintained between the top of the stub column and the base plate. The stanchion is leveled to make it perfectly vertical. After leveling, the nuts are tightened and the gap between top of stub column and steel base plate is filled with non-shrink grout. So that brings us to the end of this presentation. I hope the points mentioned here are clear to you. If you have any difficulties, you can get in touch with us at architectsacademy@gmail.com.